Right, and finally in this this series, let's have a look at inequalities and how they're used in relation to the discriminant and how they appear in discriminant questions. So, here we go. We've got to apply our understanding of inequalities when solving problems involving the discriminant. Off we go. First, a reasonably straightforward one. So it says find possible values of k such that x squared plus kx plus 2k equals 0 has real roots. And again, the key to all discriminant questions is you pick up on this little sense that it has real roots. Straight away, that's the key phrase that pays. It tells you about the discriminant, and straight away it tells you that the discriminant in this case is equal to or greater than 0. Now, just to be a little bit careful here, they are really picky on signs. If it's got real roots, it means the discriminant's greater than 0. That's our two distinct real roots. But obviously, repeated roots are real as well. And so our discriminant could also be equal to 0. Okay. If our statement up here said that the equation just had two distinct real roots, then we'd use a strictly greater than 6. But hopefully that kind of makes sense to you, that we've the need for the equal to or greater than parts of that inequality. So once we've had a good careful think about what that little statement up there means, now let's apply that to our equation. So we've got b squared minus 4ac equal greater than 0. So we've got b squared, so there's b, k squared minus 4 times a, which is 1, and there's c, which is 2k. So we've created that inequality, and so let's go about solving it, finding the critical values. So we've got critical values of 0 and 8. There's our sketch. Remember, always draw a sketch so we can have a careful think about what is going on and how many regions of this curve we're going to be interested in. And so in this case, you can clearly see because we've got greater than 0, so we're above the x-axis, we've got two distinct regions that we're interested in, which is going to give us two distinct inequalities. So we've got all values for k that are less than 0, and all values of k that are greater than or equal to 8. And so there we go, our two distinct regions coming from our inequality. So there's our solution, k equal greater than 0, sorry, equal to or less than 0, and k equal to or greater than 8. Okay, that one was reasonably straightforward. Let's have a look at an exam style question that is a little bit more tricky in places. So this is a simultaneous equations question, so we've got to look at where these two lines meet, the points of intersection, and the first part is just to create that quadratic. So we've got to get to this equation here from our quadratic there and a straight line here, and again we've got some value there that we don't yet know. So we've got to be working with values of k. So first of all, part A, we've got to prove that solving these two things here simultaneously leads to this slightly horrible looking equation. So off we go. So they'll meet when the two things are equal because they're both in the form y equals. So clearly 4 minus 8x minus x squared is going to be equal to k bracket 2x minus 9. Do a bit of multiplying out of the brackets, and we've got some rearranging to do. So I personally prefer to have the x squared coefficient positive, and we're being asked for it being positive there, which is why I've moved all of this bit here over to the right hand side. So we're nearly there. All we've got to do now is just a little bit of factorising within our x terms here. And also just be careful, you've got to notice we've got minus there and a minus there, so just make sure you're happy that if we bring that out and put a bracket in, that this statement here is actually the same as that one there. And hopefully you're reasonably happy that it is. So there we go. There's our results. That's part A sorted. So now let's move on to the discriminant part, and that's going to be appearing in part B. So it says we want a range of possible values such the line and the curve do not meet. And again, that phrase that pays on in this about them do not meet. So straight away that tells us if they're not meeting, we've got b squared minus 4ac less than 0. So this time I'm just going to be a bit more methodical and carefully think about what my values of A, B and C are going to be in this kind of horrible looking equation up here. So A is 1, B is going to be all of that bit there, and C is going to be that 9 times 4. Don't forget you've got that minus there, so we need to think very carefully and make sure we're including that. So here we go, b squared minus 4ac. Again, thinking very carefully about our use of brackets here, because we've got to make sure that when we square this whole thing, the 2's getting squared as well. And there it is. So we squared the 2 and got the 4. Again, the number of times you see students kind of not putting in this extra bracket and then forgetting to square that number out the front, but we haven't done that. And then we've got to just tidy up this thing here. And again, we've got to think a little bit carefully about signs. Hopefully you can see that minus times a minus, minus there times by that minus there, means that this whole thing becomes a plus. And in this particular case, because we've got a 4 there, another one there, we can just divide through by 4 and just make that a little bit easier to work with. Multiply out, tidy it up, and we've got a quadratic equation, inequality. I'm going to have a little look at that and think, okay, what are my critical values going to be? So I might try and factorize it, and a little bit of thought realize that factorize is not going to work, so we might consider quadratic formula, and the quadratic formula gives us critical values that are there. Ugh, not particularly nice looking ones, minus 17 plus or minus root 209 over 2, but yeah, horrible looking numbers, but you know what? The method and the ideas are still exactly the same as if the numbers read, so let's just continue onwards. First thing we're going to do, we've stated our critical values. Next thing, is now we're going to draw a little sketch of our curve. We know it's a positive quadratic. We've got the 2 points where it goes to the axes, so let's draw our sketch, and this surd here is actually minus 15.7 minus 1.27. Easy enough to get those off the calculator. We want values that are less than 0, so we're looking at that region underneath the curve there, underneath the x-axis there. So straight away we know we're dealing with one single region that we can describe as a single inequality, and there it is. There's our solution. Our values for k are between those two values, and those are the two values that mean that our curve and our original line won't meet. All done. Cool.